Hello everybody and welcome back to episode 57 of the video series in which we program an entire video game from scratch in the C programming language. I think I only got one interesting question since last time, and that question is, he says, can you leave some links to blogs/web pages/videos that talk about the details of a specific feature or subject used in the videos so we can understand more? I appreciate it. And essentially my response was, well, ask me something specific and I will be glad to answer it for you. And then their response back to me was, okay, how about buffers and memory allocations and leaks are not so clear? You talked a bit about buffers, but I didn't understand much. That's still a really big topic. So I will try to go into a little bit more detail about it right now in a pretty high level sense. But first, I want you to look at my sweet Windows terminal that I have here. This is the Windows terminal. You can get this in the Windows Store, and I have a little animated background you may recognize from Super Metroid on the Super Nintendo, if you are old school like me. Let's open up repos, game.solution. I don't know why that takes so long to load. Right. Alright, let me go to WinMain, the start of our program. And let me just clear myself out some scratch space here. Okay, so buffers. Buffers, memory allocations, and leaks. This is a big topic, and I know that I am not going to do it justice just by talking about it a little bit here, but I'm going to try to gloss over it a little bit more just to make it make more sense for this one person, because anytime someone asks me a question, I do want to do my best to answer it. So when you declare a local variable inside of a function, you can see here that I'm inside my WinMain function, my entry point of the whole program. And let's say I declare a variable like this. It's an integer and its value is 202, we'll say. So we know that on this platform, an integer is 4 bytes. So we can store up to like 2.7 billion or something, because essentially we can store up to 31 bits worth of a number in there, but we have to keep 1 bit reserved for the signed bit because this is a signed integer. Meanwhile, if we had an unsigned integer, we could store a much larger number. We could, store a much larger number in this variable because all 32 bits are unlocked. They are for use in our integer. Can use up to 32 bits. So it can be much larger, like 4.2 billion. The difference is though, since it's unsigned, you can't have a negative number in here. But the point is that both of these things take up, we know both of these things take up 4 bytes, right? Like that expression is true, and that expression is true, and that expression is true. All of these things are true. We know all these things take up 4 bytes. And back to your original question, 4 bytes of what? Like what memory are these local variables taking up? Well, they're taking up this is stack space. Okay, so these local variables are taking up stack space. Okay, so the difference between these variables, which are they're stored in stack memory, versus let's say we want to make another kind of variable that is, okay, let's say we wanted to make a string. So to make a string in C is essentially an array of characters that is terminated by a null byte, right? So let's make a string, and we're going to make it a pointer to an array of characters, and we're going to call it string. No, let's not call it string. Let's call it str, and we'll set it to null. Now, essentially, here's what I cannot do. I can't do this. That is not going to work. That's not going to work. That would either crash or corrupt something. You know, it would be no bad. It would be no bueno. I cannot do something like this. That's not going to work either, because essentially, remember, all that I have declared here is a pointer. And a pointer is what? A pointer is nothing but a memory address. So up until this point, I haven't actually allocated any memory to store the string in. And I meant for this to say hello world, not hell world, which sometimes hell world is where I feel like I'm at with this program. But anyway, no, I'm just joking. What I need to do is I need to actually allocate some memory for this thing first. So why don't I do heap alloc right there? And when you use the heap alloc API, we got to supply a handle to a heap, and that's because you can have more than one heap, but every process has a default heap, and that's fine for most purposes. Let's see, the flags can be nothing, or it can be some combination of some flags like that. I like to use heap 0 memory. I like to use the heap 0 memory flag because that instructs the heap manager to only give you back pieces of memory that have been zeroed out. You know, so I feel like that's just like a more secure thing to do. And then finally, the size. Basically, how many bytes of memory do you want? Do you want 4 bytes of memory? Do you want 8 bytes of memory? Do you want 4 kilobytes of memory, etc.? Okay, so now that we have allocated some memory, see heap alloc, if I hover over it, it returns an LP void, which is essentially it returns a pointer, which is a pointer is the perfect thing to assign to this, right? Because this over here is a pointer. It's the pointer to the beginning of a string. It's a pointer to the beginning of an array of characters. So the difference here, though, is that now that we've allocated this is not stack memory. So this is going to go into a separate area of memory within our process that is not on the stack. It's now, this memory is on the heap. When this function, let's say if this wasn't WinMain, let's say if it was some other function several layers deep within the program, these stack variables automatically go away when the function returns. In contrast, this heap memory is persistent throughout the life of the process or until you free it. So essentially, you basically use your string right here, and whenever you're done with the string, you have to free the memory that you allocated earlier. So git process heap again. I don't think you need any flags, and then you have to once again give it the pointer to that memory that you allocated. If you do not free your heap memory, then that will be a leak. It'll be leaked, and like if you lose track of it, that'll be 4 kilobytes of memory that your program has leaked that you will never get back. So it doesn't matter if the function returns. This heap this heap memory is persistent. I mean, it doesn't matter if the function returns or not. So you have to remember to free it. The difference is like if if your program exits completely, you don't have to worry about freeing your heap memory, because when your entire process exits completely, the Windows operating system will automatically free any memory that your process may have allocated. So you don't have to worry if you have a program if you know that your program is about to exit, you really don't have to worry about cleaning up your memory or cleaning up any of your resources, really, because the Windows operating system is really good at cleaning up any resources that your that your process allocated and didn't free. But if say for example you were writing like a Windows service that is designed to run 24 hours a day, days or weeks at a time, however long the machine is up, you've built some background service or whatever, well, then it becomes really important again to consider all of your heap allocations, and are all of your allocations matched up with a free? Because if you leak memory in a long running process, then that could eventually add up to a really significant amount of memory, and it could degrade the performance. It could destabilize the entire system. So yeah. So I think that's pretty much it. I think that's pretty much it. He says buffers and memory. So I mean, I use buffer and memory. I use those words relatively interchangeably. There are contexts in which one word might be better to use than the other, but in a general sense, I typically use both of those words interchangeably, buffers and memory. Um, and okay, so that's memory allocations and leaks. So yeah, I mean, I think that if I think that should probably help clear some of this up. I guess we could go on to talk about like str2. Let's make another variable here called str2, and for this one we're going to use virtual alloc. And let's see, I think address, if you supply null here, the memory manager will simply just give you whatever address it finds. And then we need a size, which is probably going to be, I don't know, we can make it, I guess it doesn't really matter, 1,000,000. We'll make it 1,000,000 bytes. Allocation type is like mem reserve and mem commit, which I won't really go into all the details of like what the difference is between reserved memory and committed memory, but basically, by supplying these two flags, I want you to reserve it and I want you to commit it. It means that I'm going to use this memory immediately. I want it allocated to me, to my process, immediately, so that no one else can have it. And then protect, I think, is like page read write. Yeah, page read write. Obviously, you can supply different values. Like if you want some of your memory to be read only, or if you want, your memory to be like read write. It's a safety thing. Like if I'm going to be putting like some CPU instructions in a piece of memory, you probably want to protect it and make that memory read only, because if someone could write into it, they could write some crazy CPU instructions that you didn't intend. Like they could do it maliciously and cause your CPU to execute some instructions that you didn't want it to, right? But anyway, so the concept though is exactly the same, and these are both essentially heap memory, they both have the same scope in that your process any function. Uh, well, let me rephrase that. This memory is not going to go away until one of two things happens. Either A, you call virtual free on it, which I'm going to call virtual free on that address, and then I guess you want to supply the same size, and then free type. I don't remember. Let me look up the. Let me look it up. Virtual free. A pointer to the base address of the region of pages to be freed. If it is mem release, the parameter must be the base address. So the idea is that you can, I guess, free just portions of the memory that you allocated. But anyway, so the difference really here's the way that I understand it is the memory that supplies virtual alloc and heap alloc. That memory it's all basically the same memory. It's process private memory. It doesn't go away until one of two things happens. Either you call free on it or your process exits. The difference is that the virtual alloc API is essentially it's better for allocating large chunks of memory, like 64 kilobyte chunks of memory or larger. In contrast, the heap alloc API, the heap manager API, you can allocate basically any tiny amount of memory that you want. Like if I wanted to allocate 4 bytes of memory with heap alloc, I totally could. If I wanted to use a virtual alloc and allocate 4 bytes of memory, I could totally do that too. But let me tell you, the virtual alloc API is probably going to give you a larger chunk of memory than what you asked for. Like I feel like, and again, my numbers may be off a little bit because I'm just kind of recounting this from memory. But if I remember correctly, if I ask virtual alloc for 4 bytes of memory, it'll probably give me 64 kilobytes of memory. So that's why, like for very small allocations, virtual alloc can be inefficient. So if you're dealing with very small pieces of memory, you want to use heap alloc. And I think the architecture is basically something like this. If we have like maybe that's not the best place to do it. Let me go to like paint.net. So we have like, and again, I'll increase the size here. Memory manager. Let's make the size a little bigger. Okay. And then, let's see, draw something like here. Call this heap manager. And then down here, we'll call this your program.exe. Yeah, so if I call heap alloc, and if I can get my arrows to work correctly, it goes the call basically goes to the heap manager, and the heap manager gives me small pieces of memory. The heap manager, however, may in turn turn around and go back to the memory manager. For example, what if you have used up all of your heap? The heap manager may actually turn around and ask memory manager, I need to grow my heap. Can I please have more memory? And the memory manager will return more memory to the heap manager, who will in turn return more memory to you. On the other hand, you can also just call straight. You can bypass the memory. You can bypass the heap manager completely and just do calls to virtual alloc right there. So, like I said, the difference is like, use virtual alloc when you need larger chunks of memory, which, like I did in my program. I can erase all this junk now, I think. Let's see, let's search. Yeah, so this right here, virtual alloc, is probably the one and only call to virtual alloc that you will ever see in my game, because this is the largest chunk of memory that I ever need, right? Is for the back buffer. And it's, how many bytes is it? It's like 92 kilobytes or something, right? 384 by 240 by 4. How many bytes of memory is that? 384 by 240 times 4. No, it's a lot. It's actually, it's not 92 kilobytes, it's 368 kilobytes, right? 360 kilobytes. 360 kilobytes. So, yeah, so if you want to allocate 360 kilobytes, virtual alloc is a good a good way to do that. If you want to allocate something really small, then heap alloc is typically a better way to do that. Like here in the blitz string to buffer function, I'm basically allocating a really small chunk of memory just for drawing a string, and that may only be 1, 2, 3 characters. So it's a much smaller piece of memory. So heap alloc is typically a faster, more efficient. Not necessarily faster. I'm not going to say faster because there's not really much of a speed difference there. This is about memory economy. It's about memory efficiency, because remember what I said earlier, when you use virtual alloc, it gives you memory, it allocates memory in really large chunks. So if you go around using virtual alloc everywhere, you're going to end up wasting a lot of memory, as opposed to using heap alloc, which is much better for smaller allocations. So I feel like I've said that in every which way that I can say it. So hopefully, sir, that answers your question. How long did that take? Yeah, I spent 26 minutes on that. Okay. Now let's move on with the programming. So I think today is kind of an interesting day, kind of an interesting episode, because I've been thinking about it. And I think today is the day that we need to start thinking about this right here. I essentially want to create a separate DLL file that contains all of the game logic, all of the game code, and then I want to basically hollow out this executable and have it just be essentially the platform layer. So let me write that down so I can better illustrate what I'm talking about. Okay, so let's say we have our game and it's called game.b.exe. However, let me make it bigger. Let's make a cooler name. I mean, like I'm getting tired of game.b.exe. Problem is like I don't have any like storyline or theme for the game yet, so I don't really know what to call the game. But let's just pretend it's called something. Let's pretend the game is called like Dragon Poop Sword.exe. That's the name of our game right now. Is Dragon Poop Sword.exe. That's the executable that the user is going to run. DragonPoopSword.exe will in turn load game.dll. So why would I want to do this? Well, there's at least two reasons why I want to do this. Uh, the first reason I want to do this is since we're making an RPG, we're making a game that is designed to have uh, a storyline that the user or the player progresses through. You travel to different locations, to different towns, you talk to NPCs, you buy things, you make decisions, you may make dialogue choices, all this kind of stuff. That's an incredibly complex game. I mean, that's way more complex than, like, say, Space Invaders, for example, where Space Invaders basically only plays out one way, right? Like the game starts and stays on that same screen, and the game loop goes until you've either killed all of the aliens or they've scrolled all the way down to you and they blow you up, and that's it. So the this is a problem for me because up until today, up until now, I've essentially been making a little change. I'll make a little change to my code, and then I'll recompile the entire game and start over from the very beginning every single time. And that's fine for now because we haven't really put any elements of player progression into the game. But that is not going to scale because imagine when we are miles down the road with this game and we've gotten to a point where I let's say I have to go conquer this one dungeon and collect this one item and then take it over to this other dungeon, and it's the key to this other puzzle, and I unlock it and I go down into this lower level of the dungeon, and then there's this other dude that asks me some riddles and I have to answer it correctly or else he turns me into a frog or something. Okay, and then I find out like that there's a bug at that part right there, and I'm like, oh, I got to fix that bug. So I go to fix that bug. I have to stop the game, go fix the bug, and then start the game all the way over from the beginning. No, that's not going to work at all. I mean, yeah, there's just no way that's going to work. So what I want to do with this concept is basically this right here is going to essentially, we don't need to recompile that anymore. And then I want to have it in the main game loop. Which what do I mean by main game loop? I mean in WinMain, which is right here. Okay, this is WinMain. Go down, go down, go down, go down, go down, go down. Almost there. Right here. While game is running equals true. This loop is going the whole time, right? So this is what I refer to as my main game loop. Essentially, I want to add some logic in here to detect when that DLL is changed. And when it is changed, I want to dynamically reload the DLL and reload all of the imports that I imported from that DLL. So say we're 2 hours into the game somewhere and we've already done several things, and we find a bug or want to make a change, like, oh, this text is white, it needs to be red, then we can make that change in the DLL file. Meanwhile, the game is still running in the background. We just alt tab over to Visual Studio, switch over to Visual Studio, make the change, recompile the game DLL. Meanwhile, our main game loop over here detects that the game DLL has changed, and so does all of the reloading. Meanwhile, the game is still running in the background, and then we go back to the game, and boom, we notice that the text has instantly changed to red from white to red because we made the change in the DLL. So that is the number one thing. Number one reason. Number one, dynamic loading of game code. Now, reason number two. Reason number two is also a big one. It's one of the most talked about features in the comments of this video channel, this YouTube channel, is, do you support Linux? Do you support Mac OS? And currently the answer is a big fat no. This game is obviously Windows only as of right now. But this architecture here, if we are successful in making this transition that I've described here, this is what is going to lead us down the path of platform independence. So essentially, this executable becomes the platform layer, and then this DLL becomes our platform independent game code. So essentially, we can take this binary anywhere to any platform. We'll have to recompile it for like Linux has its own ABI. So we'll have to be recompiled. But the logic, the code inside of it can stay exactly the same. Meanwhile, this becomes this goes from being dragonpoopsword.exe to being something like Win32 dragonpoopsword.exe, and then we can actually write our Linux code or our Mac OS code or our ARM processor code for Raspberry Pi or whatever, and we could call it Linux Dragon Poop Sword. And of course they don't use the file extensions in Linux. It could just be, I don't know what they do in Linux. Maybe it'll be a .bin or something. But anyway, the idea is that both of these platform layer binaries will be obviously very different, because this is where all of the interaction with the operating system is going to go. Things like reading and writing files, reading and writing registry keys, and things like this. Obviously, that kind of stuff is specific to the platform layer, but they're both going to load the same module that has all of our platform independent game code in it. So there you have it. That's the plan. And it scares me because it means that this project is it's going to be a huge undertaking, really. I think it's going to be one of the biggest things that we've done to this program in a long time. But it's a necessary change. I think you would agree that these two reasons are sufficient to make this big, scary change. So, with that being said, of course, I have to preface this by saying it is scary. I don't know exactly what I'm doing, and I'm very likely to have some missteps during this process while we're doing this. All I can say is I will do my best not to leave the game in an unrunnable state between episodes. So I'll at least make that commitment, is like, no matter what happens, I will make sure that the game at least still runs by the end of the episode. Beyond that, I can't really promise much. This is going to be a large undertaking. So, all right, enough talk. We got to start somewhere, and I guess I'm going to start by starting a new instance of Visual Studio, and I'm going to create a new project, I guess. So create a new project, and then of course you know me. I always start with an empty project. I don't need anyone else's boilerplate for any reason. And then we'll go next. And now, where do I want to store it? I don't know if this is going to mess things up or what? Here's what I think I'll do is I think I would like to store it inside of this repository because I don't want to make two separate repositories for the platform layer and the game code, game logic DLL. I want everything to stay in the same repository. So I think this is probably the best place to put it. And I'll call it, okay, so it's going to go in there. And what it's going to be called, what do I want to call it? Game code. Should I call it game code or game DLL or just DLL? I really can't decide. Game code. Okay, I'm going with this name. I hope it works. Alright, here's our new project. Let's go look and make sure I didn't accidentally mangle things. In our directory, source, repository, game B. Although I suppose following my own logic, I should have put the My Mini Z project inside the same folder, but it didn't. I don't want to think about that now. Alright, so here's our game code directory. Alright, let's go back to Visual Studio, and as usual, first thing I'm going to do is I'm going to add a C file to this, and I'm going to call it main.c. And remember, you have to put a C file, you have to add a C file to the project first before you go into the project properties, because this C/C++ category will not appear in this little menu over here until after you've added a C file to the project, right? So add the C file first, even if it's blank. Then we can go in here and start changing stuff up. Alright, so you know from like the earliest episodes that I do like to customize this stuff a little bit. I make this change for all configurations, all platforms. There we go. There we go. Okay, target name. Okay, this is important. We want to change the configuration type from .exe to .dll. And of course, you know, there's no magic to this. It's simply where's the command line? Release 64. All of the changes that you make in this little UI, they all translate to command line parameters. So, I mean, all this stuff can be automated if you want to, you know, do something with a batch file and set your build up so that it's completely, you know, you can completely do the build from the command line so that you're completely free of Visual Studio. You totally can do that. I mean, you can do all this from the command line if you want. But anyway, there should be, I believe there's a /DLL switch that goes in here somewhere. I think. Oh, there it is. I found it. Alright, that's enough of that. I just wanted to prove a point. Okay, Visual Studio, language standard. You can use C11 and C17 features if you want to. I think I will probably stick with C89 uh, just because I don't really know. I mean, like C17 was like basically just like a bug fix release of C11, and then C11. Actually, someone made a comment on this last time, and they said, by the way, the C11 and C17 standards are supported now in Visual Studio, and I still take that with a grain of salt because I think they're quote unquote supported. But anyway, all the required features of C11 and C17. This meant adding underscore pragma, restrict, no return, align as, align of, generic, TG math, static assert. So, I mean, if that is the sum total of C11 and C17, then I'm not particularly interested in it at this particular moment. This generic thing might be useful, but I don't know how to use those. So I'm just not going to worry about it. I'm going to stick with my old school C89. All right, let's keep going. So character set. Remember that earlier, this is kind of a refresher on episode 1 or 2, where I said the best practice is to always use Unicode character set. But this is a do as I say, not as I do type of moment because I'm using a multi-byte, which is essentially ASCII ANSI type character set, non-Unicode. So the downside is that I lose all of that Unicode support. I think my Windows API calls are um, penalized essentially because Windows is inherently a Unicode operating system. So when you call a Windows API with if you call the ASCII version of a Windows API, it has to essentially translate that to Unicode. The operating system processes it, sends it back to you. Then the system has to translate it back into ASCII before finally sending the results back to your application, back to your program. So that costs us a little bit of overhead. But anyway, it's much easier to program with. Like Unicode strings are they just sort of make things more complicated, not as straightforward. And I felt like since this was designed to be a beginner friendly project, that the more beginner friendly character set to work with is this multi-byte character set. So that's why I'm using that. Okay, common language. I think this is fine. Obviously, we're not using that. What else do I need to change? I'm going to change this to all warnings as I did with the platform layer. Optimization, all that is, the defaults are fine on all of that. Code generation. Okay, so I need to change this to debug. Change runtime library from multi-threaded debug DLL to multi-threaded debug. Apply. And then I go to the release mode and I change this from multi-threaded DLL to multi-threaded. There we go. And as I said in that earlier episode, the difference here is essentially when I'm using the version that doesn't have the DLL in it, I'm basically embedding the C runtime into the executable itself. So I am making a larger executable, but I'm also making a more portable executable because if you have the C runtime, the required C runtime in a separate DLL file called msvcrt60.dll or something like that, then you have to remember to also take that DLL with you if you wanted to like put the executable, if you wanted to put your program on like a USB stick or something. You have to remember to also have that C runtime along with it, or else the recipient, whoever you're trying to give your program to, might not be able to run it. So that's why I always like to bake the C runtime into my executables so that that is just not an issue. Like I said, the only downside is that it creates larger binaries. They're like, 500 kilobytes instead of 50 kilobytes. It's because of this big bloated C runtime library. Anyway, I think that's all we need to change. There. Okay, so here we are. This is our game code DLL file. We're going to call it Platform Independent Game Code Binary. So, what is in a DLL? Whenever you're writing a normal program, like a command line program, you're probably going to have like a function that's like int main or something, right? Like that. And then if you're writing, say, a Windows service, you might have something like you're going to have like a service main. If you're writing a DLL, you're going to have a DLL main. Okay, so these are just well-known entry points into these different types of modules, different types of applications or programs. Other than that, there really isn't much of a difference between an EXE and a DLL. They're not really any different. They both contain the same kind of binary executable code. But these are well-known entry points. And if you really wanted to, especially like I showed you, I remember on an episode a long time ago, that you can actually redefine the name of you can rename your entry point if you want to. It's just this is the well-known one. It's main or service main or DLL main. So we're making a DLL, so it's going to be DLL main. And obviously, I know that the decorations and command line parameters and stuff are different. So I might just be able to copy it off of this page here. Basically, every DLL has a DLL main. Okay, let's just search for that DLL main. It's Boolean API DLL main, and essentially you need to copy all of this. Copy, paste. Okay, and then of course these things are defined in Windows.h, so we got to include Windows.h. There we go. Oops. Input. I think just to be consistent, I think it's instance. Reason and reserved. Okay, so lesson time. DLLs are one of the more interesting parts about the Windows operating system and the internals of Windows and how it works. Every time an executable loads a DLL, the image loader automatically knows to look for DLL main and run whatever is in DLL main. And this happens automatically every time you load a DLL. You can't stop it. There's also probably one of the largest class of bugs in the Windows operating system, and they're bugs that I see in my at work all the time. If not every day, but pretty regularly, are loader lock bugs. So here's how it works. Say your process, your program, which in our case is going to be gameb.exe, right? This is our main game. I'm going to load this DLL by calling the load library function, right? When I call load library gamecode.dll, the image loader is going to automatically take a lock uh, that is global to the whole process, and the image loader is going to, or not, well, I should say the thread that is loading this DLL is going to take a lock that is global to the whole process while it's running whatever is inside this stuff. So right now, I'm not really doing anything. You can see that there are different reasons for why you might be calling into this entry point. Like for instance, you may want to run this code in here for whenever the DLL is first attaching to the process. You may want to run this code here for whenever the DLL is attaching to a specific thread. And then you may want to run this code here for whenever the DLL is being unloaded by a specific thread. And you may want to call this code here while the DLL is being unloaded by the process. However, you want to do as little as possible in this code. Number one, while this code is running, your process, the thread that is loading this DLL, holds a global lock. What that means is no other thread in your process can load a DLL. As long as you've got this lock and as long as you are running DLL main, no other thread in the process can load a DLL. That's one reason. And there's another reason why you don't want to do much inside of this initialization, is that you could easily create deadlocks if you do something that requires loading another DLL. For example, let's say that in somewhere in here, I call some code that requires loading another DLL called, I don't know, what's kernel32.dll or something, right? I can't load it. I mean, obviously this module is already going to be loaded, but let's say it's something that's not already loaded, like, foo.dll. I cannot load a DLL in this process because I already own my thread. This thread already owns the loader lock. So this one, the DLL main for foo.dll, can't run. So that's how you create basically a deadlocked process. This will hang the process, and this you'll have to go into Task Manager and right click and kill task, all that kind of stuff. So the best DLL main is a DLL main that does nothing. You want to do practically nothing inside your DLL main, but you still need a DLL main, okay? So let me simply finish writing this with the syntax that I prefer, because I like all of my my switch case things to have brackets. I don't like omitting brackets anywhere for any reason. So I will do that and that. Okay. Return. Should I return true here? Let me see. What does the documentation say? For DLL main. What does the documentation say for return? I mean, okay. When the system calls the DLL main function with process attached, The function returns true if it succeeds. Okay, that's all I needed to know. Obviously, it's always going to succeed because we do literally nothing. So this is just a skeleton of a function. This is a stub. This DLL main intentionally does nothing. And like I said, that is the safest DLL main. Everything you add to DLL main, you do so at your own risk, because sometimes you don't even know that what you're doing is going to unintentionally cause Windows to try to load another DLL. Like, for instance, you may think that you're doing some sort of network call or something, and like maybe you didn't load WinSock 2.dll directly, but maybe like you made a call that indirectly caused this thread to try to like load WinSock 2.dll, and now you have a deadlocked process where your thread is stuck. You can't your process can no longer make any progress, and you have to kill it. It's hung. So hopefully I got that message through to you on why we are intentionally choosing to do nothing in our DLL main. Okay, but what if we wanted to do something? Let's try something. Let's try a message box. Test hello world. Let's make a caption called test, and then the type will be message box okay. No, that's not how it works. MB okay. There we go. And we'll do, let's see, MB icon asterisk. Okay, so essentially this code right here, which will be message box A, this code here should run whenever any process loads your DLL. This code should run automatically anytime a process loads your DLL, even if you didn't explicitly call. You don't have to explicitly call the DLL main function. It'll run this automatically, okay? Let's test this theory. Let's go to debug, let's go to x64, and let's compile this thing. And I'll tell you right now that Windows.h is going to spew a bunch of warnings because we have all warnings turned on. So I'm going to, oh sorry, I did this wrong. Pragma warning push 0. Right? Now let's compile it, rebuild. See how much, yeah. So we're already about an hour, and we haven't even really done anything interesting. I've just talked to you all day. Let's go ahead and do unreferenced parameter instance. Unreferenced parameter reserved. Did I misspell something? I sure did. Instance. Okay. Rebuild. Succeeded. Game B. Game code. x64. Debug. And there is our DLL. And as you'll see, despite the fact that my DLL does literally nothing other than produce a message box, it's a megabyte in size. And that's because, remember, I baked the C runtime into the DLL. But yeah, here it is. We created a DLL. Now, how do we test? Let's test the DLL. Windows comes with a cool little run DLL, and as you can see, I've already been playing with it. Run DLL32. We need to specify the whole path to this thing, so shift right click, copy as path. Okay, so there's the name of our DLL, run DLL32, which that's an executable. As you can imagine, okay, so the run DLL executable is basically just a DLL host. All it does, its sole purpose in life is to load a specified DLL and optionally run one of the functions that the DLL exports. Really doesn't do anything other than that. So right now I'm going to see if this works, if this command line works on its own. What should happen is run dll.exe will spawn. It will then load gamecode.dll. Gamecode.dll, or the loader, will detect that it is being loaded, and it will automatically invoke DLL main, and will say, oh, we're attaching to a process for the first time. Let me run this code, which is message box A. So let me click OK on this and see what happens. Nothing happened. Nothing happened at all. So let's try that again. Only this time we're going to specify, actually, let me take off these quotation marks just to be safe. Okay, make sure it's not popping up in the background, which it's not. It's okay, we'll fix this. Okay, comma DLL main. Okay, there we go. So that was the problem, is run dll.exe requires that you not only supply the DLL name, but you also have to supply comma and then the function name, supplying the function that you want to run. And here it is. Hello world. Oh, and now you're telling me missing entry DLL main because I'm not exporting DLL main. So let's try that one more. Let's try that again. What if I? No, nothing. Let's see, why did I get an error? We did get our little message box. So let's move on. Let's try something else. Let's make another function, and this function we're going to call testfunc01. Okay, and we're going to take that piece out. And we're going to move it up to here. We're going to call it hello from testfunc01. Okay, build. Go back to run. Alright, so if I type DLL main here, I should get an error because that DLL main is not exported. See, missing entry, DLL main. Now if I run that again with testfunc01, I still anticipate getting an error because I did not export that function. Testfunc01, missing entry. Okay, so what we need is we need to tell the compiler, I want this function to be exported, which I do that with this decoration or keyword or whatever you want to call it, decl spec. And I think you supply like DLL export or something like this. Yeah, I think that's probably right. So this basically says any function that you want to export from this DLL, you need to put this piece on it right here, this decal spec DLL export. So let's rebuild it. Let's go back to run. And there we go. Test func is on there. Let's hit OK. And then, like magic, we get our message box, hello from test func 01. Okay, so our DLL is working. I am going to let us assume that in the end product, in the production release of this game, whenever it's all said and done, this gamecode.dll is going to live in the same directory as our game.exe, which is right there. Yeah. So what I want to do is, can I add a post-build step to this DLL project? Build, custom build step, post build event, command line. Game code. I don't like this. Copy dll.bat. Okay, copy. That. Wait. Copy as path. Copy that to game B. x64 debug. There we go. And what's the switch to overwrite? Is it /F? /Y. Suppresses prompting to confirm you want to overwrite an existing destination file. /Y. Okay. Save. Okay. Save game code. Rename this to 64. Copy, rename, copy DLL 32, edit. That was weird. I'll close that. Edit. Okay. 86 to 86. All right. Save. Okay. Copy DLL32.bat, which I don't think we have built yet, so I expect that to generate an error. System cannot find. It's past specified. It's too long. Right, copy DLL64. There we go. One file copied. There's our gamecode.dll. Okay. I think that's right. The good news is we only have to do this once, right? So this is release. I don't want to do all platforms. Hang on. Debug. Do you want to save the changes? No, I don't. Debug x64. I need to change these again. Game B. Rename. Copy DLL32 debug. Debug. We take one more look at them to make sure that they are in fact debug, which they are. x64 debug and x86 debug, x86 debug. Nice. Let's copy both of these again. I'm going to call this copy DLL32 release. Release. Close and save. Rename you to copy DLL64 debug. No, copy DLL64 release. Edit. x64 release. x64 release. Save. Now, post build. Configuration, debug, x64. x64 debug. Will be this right here. Description, use and build, yes, okay. Now, let's see if this works. It probably won't because I have to use a path or something. Oh, it actually just worked. Didn't it? No? Yes? Maybe? I have it on x64 debug. x64 debug command line, copy DLL64 debug.bat. The output of which game B, x64 release, x64 debug, game code DLL at 3:22 p.m. Pretty sure that's it, but I'm going to delete it and rerun this anyway just to make sure. There it is. Okay, it actually works very well. Let's finish these. Okay, on release, debug 32, copy DLL 32 debug, release copy DLL 32 release. Oh, you know what? I misspoke earlier. I said something incorrect. When I said earlier that the size of this DLL module was due solely to the fact that the C runtime was baked into it, that's not true because remember, it's only partially true. The release version will also be smaller. The release version will also create a much smaller binary because it doesn't have all that extra debug information in it. So, okay, all right, awesome. All right. Now, on to doing something useful. I know I'm going way over time, but I think this is the kind of episode that warrants going way over time. Now, here is what we need to do. I'm going to go back now to gameb.exe, and I'm going to go down to, I'm just going to go down to WinMain again. Now, this is the very beginning of our game starting up. We're doing all this platform-specific stuff. And by the way, you know, importing functions from a DLL should not sound difficult to you because we've already done it before, haven't we? We have already done it before, right here in tQuery timer resolution. We're already doing it. We're getting this function from another DLL file called ntdll.dll, which is, you know, part of Windows. So we've already done this part before, so this won't be new to you. So that's cool. So we need that. Okay, the question is, where should I load my game DLL? Obviously, we need to load it once early on. Let's go ahead and load it really early. In fact, we'll load it even before, actually, we'll load it right after checking for this global mutex. Or, wait. No, we can't do that. Where is game running? Game is already running. Okay, I guess I'm going to do it like the very first thing. All right, how do we load a DLL? Is with load library, and it's going to be called gamecode.dll. And might as well, you know, go ahead and pound define that. So we'll go over to main.h, we'll make a pound define somewhere in here. I want to do it over here near, here it is. Okay, let's do it here. Define game code. I mean, even the word DLL is not platform independent, right? So we'll just call it a module. Instead of calling it a DLL, we'll call it a module. And it will be named gamecode.dll. So then later on when we go to make like a Linux version of this platform layer, we'll just change this name to something else. Because it probably won't be named .dll on other platforms. I mean, it could be. It doesn't really matter if you have file extensions or not in Linux, right? I like to line everything up here. Okay, back to main.c. We're going to load game code module. What are the parameters here? Just a file name, okay? H module, which is a handle to a module. Game code module. And I'm sure that if that fails for some reason, then it will return null, but I do like to check these things just to be on the safe side. Load a library. If it fails, the return value is null. If game code module. And I'm not sure if I like these variable names. I may change it later. But for now, if it equals null, that means this failed for some reason. We need to log it, and then we need to go to exit. Go to exit. Yeah, we can't even log yet, so I'll just use a message box then. Load library failed. Make sure game code module. Make sure game module code there. That should do it. But you know what? Now that I'm thinking about this, let's take this, let's back this change out. This is going to be a pretty advanced thing. So what I actually should do is create another function. Create a new function, and I'm going to call it something else. I'm going to call it dword, or maybe I'll just make it a bool. Load Win32 code. Load code. Load game code. And I guess if we ever wanted to have like multiple versions of our game code DLL for testing or whatever, we could do let's see, module name, module file name, right? Create definition for load game code. Paste all that junk in there. All right, fine. That's pretty cool. I didn't really realize that Visual Studio would do that, where if you create a function declaration right here in your H file, it'll actually insert, and then you know if you use that little tooltip trick that I just did to automatically insert it into main.c, it'll actually put the function in the appropriate place between the two functions where I put it, where I put the declaration, right? Somewhere between main window proc and create main game window. So that's pretty cool. I didn't really realize that it would do that. I'm glad that it does. It's cool. All right, load game code, and then of course change this to module file name. No. Bool result equals I guess I want the default to be true. Oh, actually that was correct. Go to exit, and then exit will be here. Return result. Okay. No, I don't like this. Let's make it a D word. And let's make this a D word. Load game code. And this needs to be I guess I could take this away and instead just return get last error. That should work, right? Okay. Okay, next we need to essentially what do we need to do next? We'll do it right here. If load game code, and then the module game code module is not equal error success, which is 0. Then we are going to complete. Error this failed to load module %s. Okay. I mean, okay. If it's not error success, log message. %italics. You are going to be get last error. keyword result equals error success. Dang it. Autocomplete. Useless. Okay. Result equals get last error. Okay. Let's see. If result is not error success, then we say function failed with this error result. And then I finally return result. There we go. Okay, so the next thing I need to do is I need to start essentially digging out the functions, hollowing out this program, this application, this game, and taking the quote-unquote platform-independent parts of it and putting it into the game code DLL. Also, I need to start converting these function declarations into type defs that look more like this. Because now that the functions are going to come out of a DLL file, I'm not going to declare them here in the same way that I have been. I'm going to declare them this way because they're going to come out of a DLL file. But since I've run so far over time today, I am going to save that for next time. That's all I have for today. So as usual, thank you very much for watching. If you enjoyed what you saw and you would like to continue seeing this game being developed, then please hit the like button. Please subscribe to the channel. Please tell your friends about it. Don't forget that we have a GitHub repository online. I keep it updated along with these episodes so that you can clone the repository and follow along at home. If you have any questions or comments, please don't hesitate to ask any questions you may have. I will address any interesting comments or questions in an upcoming episode. So, until next time, thanks again for watching. See you later. Bye.